Hey, this is Mr. Kruns, and in this video I'll be reviewing piecewise functions and the average rate of change. The first one we have is to graph a piecewise function. It's going to come at two pieces, and basically there's going to be a line down the middle where we kind of sew two different functions together. This time it's at 1, so I'm going to put kind of a very light line there. It's not officially part of the graph, it just helps me remember. And you guys can't always see that, so let's make it a little bigger. Okay. Now, whenever x is smaller than 1, so we change this side right here, where x is less than 1, we know that the graph will be equal to -1. So anywhere on this side, I should have -1s, which ends up just being a straight line and going off the graph. Whenever x is greater than or equal to 1, we should graph the line 2x minus 1. Lots of different ways to graph a line. I'm just going to plug in 2 points and then sketch it from there. If I plug in 1, I get 2 times 1, which is 1, and 1 minus 1, 2 times 1 is 2, and 2 minus 1 is 1. So it starts here, and then if I plug in, say, 2 times 2 would be 4, 4 minus 1 would be 3. There's my 2 points, and this one's going to go up like that. The only last piece to look at is which one of these is included. If this is going to be a function, I cannot have a point that's here and here, because that would fail the vertical line test. I look at the one that is greater than or equal to, and that's the one that will have a big closed circle, which is this top half. And then the other one, to say that we're going up to 1 but not including it, we put an open circle. Rewriting a absolute value function as a piecewise function, I'm going to break it into 2. And basically, well, if x minus 1, the quantity, is greater than 0, the absolute value wouldn't actually do anything. So in that case, I can just do x minus 1 plus 3. I can pretty much treat the absolute value as parentheses. On the other hand, if x minus 1 is less than 0, I would get a negative number here, and then I would know to make that negative number positive. A nice mathematical trick for doing that is to take the opposite of whatever you come out with. All right, so there's my setup, and now I want to simplify this. g of x is equal to, let's see, the parentheses here don't do a whole lot, so I have x minus 1 plus 3, which gives me an x plus 2. If I distribute this, I get negative x plus 1 plus 3, which is a negative x plus 4. Solving these two statements for 0, I could add 1 to both sides to get x is greater than or equal to 1. Add 1 to both sides here, and I get x is less than 1. This is my simplified final answer. All right, for average rate of change, this is trying to estimate basically the slope. For this one, this is an interval now. That's really important. This is not an ordered pair. This is an interval. It's an interval of x values. So I want starting from x value of -1 and then going up to 2. To do this, I'm going to find the change in y divided by the change in x. The change in y is going to be subtracting the outputs of the function. So it'll be f of 2 minus f of -1 over 2 minus -1. For this, I need to find f of 2 and f of -1. Oh, excuse me. So f of 2 here, I use function notation. I have to plug in 2. So 2 minus 2 squared plus 3. 2 minus 2 is 0. 0 squared, 0, and then adding 3, I'll get 3. F of -1. So plug in -1 where x is. So -1 minus 2 squared plus 3. -1 minus 2 is a -3 squared. -3 squared is 9. And then 9 plus 3 is 12. So now that I know f of 2 and f of -1, I can substitute these quantities in. F of 2 was 3. F of -1 was 12. then 2 minus negative 1 is the same thing as 2 plus 1. Subtract, 3 minus 12 is negative 9, 2 plus 1 is 3, and I can simplify that to a negative 3. Right. Very similar to graph, except for the way, instead of finding out these guys, we could either just count the rise and run, or we could still do it with some points. In this case, just for contrast, I am going to count the rise and run. Again, there's my interval, so I want to find where x is 1 and where x is 4. And when I go from here to here, I want to say how much on average is the y changing. To do that, you find the points. In this case, it's actually right there. Then x is 4, the graph is up here. If I go over and I go up, I have that the change in y would be equal to a positive 3 because it's gone up 3. And the change in x would also be a positive 3 because it's gone over 3. Therefore, my average rate of change in y over change in x, is equal to 3 over 3, which simplifies to 1.